everyone. Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Hailey Joren, a Ph.D. student at the University of California, San Diego. Hailey and her collaborators at Duke University and Google have recently published Sufficient Context, a new lens on Retrieval Augmented Generation Systems. Hailey, thanks so much for joining the Weaviate podcast. I'm super excited to discuss these things with you.
Yeah, I'm super excited to be here.
Awesome. So maybe even before diving into the technical ideas, do you mind explaining the sort of meta around the project and your research journey that led you to be working on this?
Yeah, definitely. So kind of the background of the project is this, retrieval augmented generation systems, where we give these LLMs additional context to be able to answer a query. And ideally, the LLM gives the right answer or responds with, I don't know, if the needed information isn't in the context. But a lot of times this doesn't go exactly as planned, and we see hallucinations, we see errors. And the motivation behind this project was to really understand why and to really dig into these types of failure modes.
Awesome. Yeah. So can we maybe just kick it out right at it? I think there's so much interesting work around detecting irrelevant context and hallucination detection. It kind of maybe to jump in about my interpretation of the sufficient context. It really reminds me of in the sort of RAG evaluation days, we had the RAGIS metrics, and one of them they were kind of like a collection of 4 prompts for LLMs judge ratings. And so maybe we could just kick it off by sort of your definition of sufficient context and how you explain this way of looking at it.
Yeah, the motivation for like the idea of sufficient context is sort of a different metric than relevance. So relevance is important. We want to be able to evaluate the context, but it doesn't really tell us if the model should be able to answer the question given the context. So we wanted to measure something a little bit different. So that's what we're calling sufficient context. It's a pretty simple definition. We define it as should we expect the model to answer the question given this context? So we have a little bit of nuance. We allow some like reasoning, some like multi-hop queries, but the core of it's pretty simple. Is the context sufficient to answer the question? This is different than relevance, which just kind of answers how relevant to the query is this information. And you can imagine information that is relevant, but actually not sufficient. But of course, like all sufficient information should be relevant.
yeah, yeah, it's awesome. I really like the sort of breakdown of the particular cases. Like in our last podcast with Nandan Thaker, who's done a lot of work on RAG benchmarks, we were talking about insufficient context that's handled in the ambiguous query. Like if you say, "How do I change the tires of my car?" and it's like, "Well, what kind of car do you have?" and that kind of case. Yes,
Hmm.
maybe the paper starts off with this. I wrote it down. I really wanted to ask to clarify this. Attributable to identified sources way of looking at it. Do you mind explaining further how that particularly uh, grounds us?
Yeah, so that's related to this idea of like disambiguating, so attributable to identifiable sources, and that there might be something ambiguous in the query itself, like what does 404 stand for? And that kind of depends a little bit on the context. So we might need to disambiguate like 404 in the context of like a page not found error means X. Or even questions about people, especially is something we saw with ambiguous queries like who is Leah's spouse, without specifying like who Leah is, like things like that. Yeah, that's so we want to be able to like attribute to a specific source and say, where does this query really fit in among all the information we're providing?
That question about who is Leah's spouse without first saying who is Leah, it really inspires me. I think one of the big buzzwords in AI right now is context engineering, and so
Yeah.
maybe it always just kind of motivated me to say maybe you want to have retrieval from like your knowledge base as a standard kind of vector database thing, but maybe and then kind of graph rag is another thing that's emerging. Like you create a knowledge graph, an ontology of all like the key words in your business, but and I think about maybe you would want to have like a vector data, a similar kind of knowledge base, but it just has facts. But aside from this thing, just like how do you think about that term, context engineering, that might give you that background of who is Leah before we figure out her
Yeah.
spouse?
Yeah, I think the context engineering in my mind is sort of like the next phase after we worked so hard on like retrieval quality and just being able to get things that are relevant in the first place. And now we're kind of on to the next step, where we want to know, how do we piece these things together? How do we make sure that this context even makes sense as a whole? Do we have contradictory information? We're kind of moving beyond just relevance into information that these LLMs can actually use.
Yeah, I'm curious what you think about taking a little bit of a detour from the paper to just explore this context engineering idea a little further. Like, how much of it might live in the prompt? Like, if I'm a chatbot and I'm chatting with me, Connor, and is building this prompt about who I am, maybe it's baking that into the parameters of the large language model, even. And I think that's a really interesting. That's my favorite takeaway from the paper. I'm not going to jump to it quite yet, but that kind of parametric knowledge conflict of what's in the LM, what is in the context. Yeah, I guess just maybe if we could think, just to ask a little further about that context engineering, is this something that you think, like having this background context? I'm just so curious about it. Like, maybe have you thought further about just what that might entail?
Yeah, I think that is a huge unsolved problem is how much of this should be in the model, how much of it should be in a fine-tuned version of the model, and how much of it should be in the prompt is a hard question to answer. Part of that relates to how flexible we want the model to be when presented with contradictory information, and how good do we want the model to be at abstaining or like the ability to say I don't know when it doesn't know the answer or when the information, we have insufficient context. Um, yeah, I think we're not quite there yet. And it's something I think the research community is really looking into is what is the right way to kind of handle these issues. I think, from my perspective, it's a little of both. I do think there's a place for fine tuning these models, especially, for some of these enterprise applications, even for kind of narrower sets. We're also starting to see, fine tuning for like individual users, I think is also interesting. Um, but yeah, I still think a lot of it's going to be in the prompt itself.
Yeah, I think I'm in that phase too. I've seen some cool work around like personalized LoRa fine tunes where you have like a LoRa for each of the users, and that's pretty. I can imagine like a multi-tenant LoRa. It's a cool way of thinking of it. But yeah, and I really like
Yeah.
this company called Letta AI that has this kind of like their take on memory is that you have this self-editing prompt and it's kind of forming its identity. And I think that really works nicely if you take this like agent, almost like personification, anthropomorphization. I think this like you're really humanizing the agents and they develop their roles and so they edit their own prompt and kind of like this autonomous learning. Awesome. Well, yeah. So I'd love to transition back into the kind of the ideas in the paper. And maybe it even comes into this AutoRater idea. So you've annotated a data set of the sufficient context where you have the question and the context, and then you build up this data set. And so maybe coming into what we just talked about, you could have this background knowledge, but besides from that, do you mind just kind of explaining that process of curating this data set of sufficient context? And,
Yeah, this was an important challenge we faced in the paper because, as I think we have broadly understood, we need kind of these auto evals, LLM evals, but we also really want to be able to trust them and make sure that they're accurate. So we didn't want to just take like an out of the box LLM and just label all of our context as sufficient or insufficient. So this was like our really important kind of validation data set. So what we did is I took a bunch of questions from things like natural questions, Hotpot QA, music, just a bunch of data sets, sort of changed some of the questions and kind of hand curated different pieces of context. And then I had a bunch of expert human annotators, mostly researchers and collaborators, go through and individually label each of these pairs, the question and the context, as insufficient or sufficient to answer the question. So this gave us like our gold standard data set that we could benchmark all of our methods on. So we could say, given some particular model or prompting setup, LLM eval, how good are we at actually labeling sufficient or insufficient context?
Yeah, super cool. And kind of coming back to the raggeds thing, it felt like a natural next step would be to start building big data sets of each of those metrics and maybe fine tune models. And there was another paper called ARES, ARES from Stanford that was kind of about compiling these LLM as judges. And yeah, it's very interesting. This kind of like training models for LLMs. There's been a huge thing in like the kind of AI observability category, like Patronus AI. They've trained a few models that do this. Yeah, and so maybe kind of jumping a bit, and then maybe coming back. This separation of sufficiency and relevance. I think that's one of those devil in the details thing that's really cool. I'm kind of wrapping my head around it now as we're talking about it.
Yeah.
But yeah, I really like. So if we could dive into the results from table one of the paper, where you've created this data set of sufficient context annotations, and now you're evaluating the Gemini, GPT, throwing the a lot of LLMs at it. Yeah, what was your experience with that?
Yeah, this was where we got some surprising results. So what we expected initially was that we'd be able to cleanly divide these failure modes into, when the model doesn't have sufficient context, it should abstain, but maybe it hallucinates instead. And then when the model does have sufficient context, it should get the answer right. And that was sort of true, but also not true in many cases. So we found, especially for the smaller models, they really struggle to answer these questions even when they're given sufficient context. So smaller models like Gemma, we found essentially wasn't able to really use the context, even when we knew like the answer is right there. You should be able to get this question right. And on the flip side, we found this like surprising phenomenon where even when given insufficient context, the models were often able to get the questions right, even when they couldn't get the question right without any context. So somehow providing context that isn't able to answer the question by itself would lead these models to get the right answer.
Yeah, so I think the paper it says 35 to 62% of the answers are still correct even with insufficient context. Which, yeah, I think this is maybe the most complicated problem I've seen in retrieval augmented generation is that you might want to encode some knowledge into the language model as well as the retrieval, and I think I guess maybe this kind of jumps ahead a bit of how I was planning our interview, but I'd love to kind of because I think the conclusion you come from the paper was saying that you shouldn't just have a sufficient context rater that says whether or not you need to retrieve again. It might be worth continuing to answer the question because it still might get it right because the language model might be able to answer it. And then you present this selective generation method for just how you're now going to build a system that utilizes information. Do you mind explaining how that works further?
Yeah, definitely. You summed it up well. We initially thought this will be a great method for telling us when we should abstain, when the model should say, I don't know, and when we can proceed. And that turned out to totally not be the case. Like if we have some results like that, you can see in the paper, if you go that route, you'll actually end up with, on average, worse performance because you lose all of these, right answers that the model gets with insufficient context. So what we did instead is we tried to treat the sufficient context as more like a signal to know, this is like a hint as to whether or not we might, want to abstain or not. And the other crucial piece of this was the model's own self-rated confidence. So essentially what we did is we combined these two pieces, the probability of sufficient context and kind of two different ways to measure the model's self-rated confidence. One of them is p-true, which is pretty computationally expensive. And in other cases, we just did basically a simplified version of p-true, which is, yeah, just to oversimplify, essentially how likely is it that the model is going to get this question right based on the, model's sort of outputs. And combining these two actually seems to work pretty well. So what we find is that, say compared to just using one of them alone, so say like on Gemma, maybe we just use the self-rated confidence. If we add sufficient context, we get gains of over 10% for Hotpot QA for one of our benchmark data sets. So what that means is that for like a given coverage region, like how many of these questions can we answer with high confidence? we see a jump of 10%. So that's pretty significant. Similarly, for Gemini 1.5 Pro, we see like gains of over 5% for the similar coverage regions.
Yeah. So how are you evaluating that confidence? Because I can imagine I could have a Boolean value in my structured output where the first thing it's going to output is confidence about answer. And it's like true or false. And something that I love about how these systems are playing out is you could have these streaming outputs. So you could stream that first structured output, and if it's false, then you just loop right back and you save the extra tokens. Is like a cool way to just make it faster. Yeah. So how do you think about the question answer, the final step where it's generating the answer, assessing its confidence?
Yeah, that's a great question. So the like traditional P true from like the Catabath paper and Lee et al. Is pretty computationally expensive. So it's like sample the model many, many times, prompt the model across like, multiple prompts, label each of these as correct or incorrect. The model's like labeling them as correct or incorrect, and then you get this final probability of correctness. But we found like as a kind of simpler approximation, we just called it P correct. We just have it generate a probability. So, like, what is the probability that you think this is correct? And that seemed to actually work pretty well. So, I do think we could take that further and especially go, on a token probability output level and really use that as a signal for like our kind of like last mile delivery to getting to the right answer.
I remember there was the flare technique, of like active retrieval, where yeah, you're like multiplying the log probabilities of the
Mhm.
outputs to. I meant yeah, I, I love that one, but it sounds a little confusing compared to just having the structured boolean. If I could get away with that, and that
Yeah.
other approach you mentioned, that like generate then verify, is that correct? The
Mhm.
P true is so maybe I sample 100 different answers, and then I have kind of like a network of networks way of thinking about it, or then like pruning them. Yeah, maybe we could talk. So also with the data set that you annotate of sufficient context, you get these. I think like it's like 80-90% of how well it can accurately detect this. So is this a line that this is the same kind of thing we're talking about with the confidence?
Yeah, so those are different actually. So this like second kind of confidence, this is like the model's self-rated probability of, say, I'm the model. How likely do I think it is that I got the right answer? We're sort of approximating it by having the model label its own answers and then averaging over those labels to get a probability. Um, the this other like AutoRater probability of correct, that's just like the AutoRater's accuracy. So that's like 80-90% of the time, our AutoRater is able to detect sufficient context accurately. Like it's can accurately say whether this context is sufficient to answer the question.
Oh, yeah, super cool. And then, so one other thing I saw from the table one in the paper is that you rate sufficient content, or yeah, it's the auto rater with and without the answer, and you find a big improvement
Yeah.
with using the answer as well. Yeah.
Yeah, so we experimented with a few different techniques. So we used Gemini 1.5 Pro, one shot, zero shot, and then we also used like these methods that require the ground truth answer. It was kind of surprising. We did experiment with if you just also include the ground truth answer, how much does that help? And it seems to help somewhat. Um, but relying on a method that requires the ground truth answer, actually, you would maybe expect it to do really well, but it doesn't do maybe as well as we would have thought. Part of that might be related to the model size, like some of these models are just smaller. We also, one of our baselines was just does it contain the ground truth answer? So then you just compare like basically a string matching approach. That does okay, but as you can imagine, there's a lot of nuance there that it can't really pick up that you kind of need a language model for. The other thing we used was this flame model, which is kind of like a super fine-tuned palm that's just 24 billion parameters, and it's trained for like exactly this type of task. It's trained like the fine-tuning is essentially over lots of these types of data sets. It's like a super LLM eval model essentially, and we found it does pretty well, especially for its size. So when we were doing some of our later like abstention mechanism experiments, it was too expensive to really, label each of these samples as sufficient or insufficient using like 100 billion parameter model. So instead, we just used Flamed, and we found it worked quite well.
Oh, super cool. And then Flame, so 24 billion, is it, well, because doing the project with Google, maybe they already help you host it. And so that's kind of, so to ask the question
Yeah.
of like, how's the hosting of it? But awesome. Yeah, it's all super interesting. So one question I had, when I then was like, okay, I have to go take the sufficient context rating to my RAG data set that I'm using. And just sort of my experience with it, when I find questions that even with the gold answers, it's insufficient context, it motivated me to want to consider further these like knowledge acquisition tools. This is like maybe I want to take these examples and then say use web search or ask a human, or maybe with these coding models run a coding experiment. I'm curious maybe what your experience was once you're looking at insufficient context examples, and then what kind of intervention that inspired you to want to do to maybe the data set. And yeah.
Yeah, definitely. That was really the inspiration, like that exact problem for this abstention mechanism, because ideally you want to be able to take a second step. Like you don't just want like a single layer mechanism that just either gets the question right or hallucinates. Ideally you could get the question right, and then if you can't, do something else, like, query some other corpus, or do, a more expensive retrieval, or even query a more expensive model. Like you have some kind of recourse elements ideally. But the very first step to being able to do that is, an accurate abstention ability, which says, I do not know the answer to this question, thus, take action A, rather than just hallucinating.
Yeah, awesome. I think let me maybe come back to that topic of this knowledge acquisition tools and that kind of thing, and just talk a little further about abstaining from the answer. So one of the findings from the paper that is really surprising and interesting is that when you're using retrieval augmented generation, the models are less likely to abstain and more
Yeah.
like yeah. So you mind explaining that one further?
Yeah, that was another thing we found really surprising. So it was kind of this interesting phenomenon where it's almost like when we add retrieval, we lose this ability to abstain. So, for example, Gemma goes from predicting, like hallucinating 10% of the time to 66% of the time when you have sufficient context. So it's like this massive jump going from being able to say, I don't know, to suddenly it seems to just lose that ability. We found that across all of the models, essentially, from the large models, Gemini 1.5 Pro to Gemma to, Claude, ChatGPT, like all of these models essentially lose this important ability to abstain once you add a bunch of context.
Yeah, so maybe it's so I guess maybe if I could get your take on the lost in the middle problem. I see all sorts of takes on this, whether it's, you know, these long context models are just perfect, or it sounds like from what you found that, it's very much still a problem. And I think it also comes back to what we're talking about context engineering. Yeah, what do you think about the lost in the middle problem?
Yeah, we definitely saw the lost in the middle problem. We even saw it in our labeling of sufficient context. It's even hard to label a piece of context as sufficient or insufficient when it's incredibly long. So, and that's, including for these long context models who are trained to do exactly that type of task. Um, it's an interesting case where you see both, right? You see the model is not able to pull the information out of these really long contexts. And we see, it really depends on the placement. If we move the kind of gold answer to the beginning or the end, it gets easier. We see it in the middle, it's harder. We also saw, depending on how you compose the context, so where you're composing chunks, how much metadata you include, even affects how well the model can do. Suddenly, it's not able to find the right answer. And at the same time, when you add a bunch of irrelevant context, it suddenly hallucinates more. So it thinks it knows the answer in some sense when, you've actually just provided a bunch of irrelevant context.
Yeah, that the inclusion of I think yeah, generally this whole thing is so interesting that kind of like uh whether I should what should I set the K for retrieval? Should I retrieve 5 results, 10 results, 20 results? And like if the I guess that's kind of the funny like juxtaposition of long context models and RAG is the better models get at long context, the more people think they don't need RAG and they're just going to give all their information for every inference. And then at the same time, it's like, well, RAG gets even better because I can set K to 50 maybe.
Hmm. Yeah, definitely. And yeah, that's something we saw too is that like if you look at our table of like how does the sufficient context percentage change as you change the number of tokens, like for 10,000 tokens versus 6,000 versus 2,000 tokens, you do see a drop, but it's not a huge dramatic drop. So to me, one of those takeaways was that in many cases, you could get away with truncating your context order and likely get better answers.
One thing I've been curious about, I've been just getting, trying to get expert takes on is this kind of search results summarization. I think especially with parallel searches, like if I'm writing, I have a query writer that decomposes the complex query into 4 questions and it summarizes each of the search results. Yeah, it sounds like from your experience that that would be something that you would be in favor of. I personally, I like it.
Yeah, I think so too. It does seem like if we're able to get more high quality context that is shorter versus just a long kind of uh, juxtaposition of just like everything, we're unlikely to get as high quality of answers. And that's something we found. So we ended up actually implementing the sufficient context method and idea into the Vertex AI RAG engine. And that was kind of the inspiration, was we wanted kind of an LLM re-ranker that could use some of these ideas to be able to choose the best context to provide our RAG engine.
Yeah, do you mind just explaining that further, like integrating this information with the re-rankers?
Yeah, so the idea here is that basically there's like the Vertex AI RAG engine that has a bunch of different, retrieval mechanisms that we can use. Um, and we're using all of these to get our context to provide, our RAG engine for some maybe like enterprise application so that we can keep all the information private, like the typical kind of RAG setup. Um, and it's a tricky trade-off of how expensive of a retrieval mechanism do you want to use versus how high of quality results do you want to get. So, kind of like a new trade-off, which was like higher latency, but also higher accuracy and like moderate cost, was to do the sufficient context, like LLM re-ranker, where we're using sufficient context to decide how to prioritize which context to provide at inference time.
Yeah, that's kind of been one of my big motivations with sufficient context and looking into this is I'm very curious about like a really concurrent RAG pipeline, kind of similar to the Vertex RAG engine. We're building the Weaviate query agent, which is doing it kind of has like the text to SQL thing as well as this advanced RAG pipeline. But so I've been really curious about this idea of having I guess what's called vanilla RAG or traditional RAG, where you just do kind of search and then generate, and then I feel like this sufficient context rating could help you prune that one while in parallel you're running a more sophisticated query writer thing, or you do that kind of like semantic caching thing where you've already saved answers and it could just retrieve an answer, assess if it's sufficient context, and then or I suppose because sufficient context has this nuance of being particular to the question, but yeah, send it back in. Maybe even I want to kind of I think maybe we went a little too quickly over the sufficient context because I really have just learned from our interview and unlocked that kind of difference between sufficient context and relevant search results. Um, can we maybe talk more about, say I ask a question that just I don't have, I've never, my document don't contain exactly the answer to my question just because like it's a totally novel kind of question. But then the search results, they're like they may be relevant to my question, but then like, but are they sufficient to help the LLM then extrapolate to kind of this new answer? Is that the right way of thinking about it?
Yeah, yeah, exactly. So there's kind of two key pieces of like why sufficient context versus relevance. One of them is we really need this notion of sufficient context to dig into these failure modes. Like if we're just looking at relevance, it doesn't really give us information about how or why these models fail and when and really what's going on. Like, is it the model that's not reasoning well, like, we saw in these Gemma cases, or is it that our retrieval is not very good and, it essentially gives us hints as to what we should work on improving and, where our efforts would be most valuable. And the second piece of it is that if we found sufficient context to be a good like partial signal to know when the model should abstain. So if the model has low confidence that its initial answer is correct and we have low context sufficiency, that's a very strong indicator that our answer, if we give an answer, it will be a hallucination. So it's kind of like a hallucination detection signal.
Yeah, and then I think another part of it is that sort of detecting contradictory evidence, or I think this is called ambiguous context. Yeah, I find that I think there's been all this work on fact verification. I'm not sure that
Mm.
quite is exactly this problem, but yeah, how do you think about if the search results contradict each other and how to deal with that?
Yeah, in our case, like if we have contradictory results with each other, then we would call that, insufficient context. That said, there's a tricky nuance with like the context can be sufficient, but it might contradict the model's parametric knowledge. So that still will pose a problem, of course. Like we can say, you know, say the question uh, relates to some kind of current event, but the model believes something that, was true at training time. We still have to resolve that ambiguity. Um, and it's sort of unclear, like that is a little bit more on the pre-training and fine-tuning side of how flexible should the model be to kind of like user inputted information.
Yeah, that always reminds me of early, like a super early Weaviate podcast is with Nils Reimers, who is one of the pioneers of text embeddings, and you saw always explain Corona and whether you mean like coronavirus or the beer and that kind of yeah. Yeah. So it's a super interesting one. And it kind of, maybe I can revisit that knowledge acquisition, like kind of what to do with the insight. Like, I have my production system, I have my questions, and I imagine like the workflow I'm imagining of how to use this is I store the log of my questions and answers in the context retrieved, and then I'm rating them with insufficient context. And now I want to try to fix my knowledge base. So yeah, so maybe like if you have contradictory evidence, then maybe I say, like I asked Connor, hey Connor, does Corona mean beer or yeah? So maybe yeah, just thinking maybe about how you might think about yeah maybe resolving these knowledge conflicts by maybe doing like a ask human, or you have like tools to yeah.
Yeah, definitely. So I can imagine, like, there's two parts. One is the context sufficient to answer the question in and of itself, or does it contain contradictory information? Um, as we've seen, just having insufficient context doesn't necessarily mean that the model's going to get the question wrong, even if the model would get the question wrong without context. Like there's a tricky sort of nuance there that we can't be too heavy-handed and just use it as a signal by itself for whether or not we should answer the question. So we do need to combine it with some other signals that give us more information, like some kind of hallucination detection, some kind of self-confidence rating score or something. Um, the second part is that we also can imagine a version of sufficient context that's more like ambiguity detection, in which maybe we know if we have, self-contradictory context, then that is a clear signal that we should, dig a little bit deeper, query a human, pass this query somewhere else.
Yeah, awesome. Yeah, I guess I just like so many times I'm looking at a RAG benchmark and I'm just wanting to change the corpus instead of the model or anything like that. And
Yeah.
uh, yeah, so this is a question I'm just super excited to ask your experience about. Is yeah, so there's another paper called Retrieval-Aware Fine-Tuning that's kind of it made a ton of sense to me. Like the people from contextual AI call this Frankenstein RAG, the way that we currently have frozen embedding models, frozen LLMs, and we're just kind of hoping that this idea of putting the context in the input isn't too much of a task adaptation for the pre-trained language model. But another idea is, what if we fine tune the language model with retrieved context? And so you did this experiment with fine tuning the Mistral 3 model, and yeah, so I'd love to just know everything about that.
Yeah, definitely. So we had an interesting experience with fine tuning, in that our goal with fine tuning was, we noticed this problem. The models are losing their ability to abstain when you add context. So maybe we can just fine tune to fix that. So essentially, we fine tuned on these like curated corpuses that, we are essentially imputing I don't know. So that instead of fine tuning, this question gets this answer and this question gets this answer, we're saying this question gets I don't know, and this question gets I don't know, and this question gets the answer with, different mixtures of what this should look like. And we had a surprising experience where, we're using LoRa and QLoRa, and it just didn't seem to give the results we expected. So essentially, what happened is that the performance went up. So, we're fine tuning, and we do see better performance, but it didn't really resolve this ability to abstain. Like the model was still, I don't know if you would call it like stubborn in some sense, and that it, essentially didn't recover its ability to say, I don't know, in the way that we hoped that it would.
I guess to fire a couple of quick questions at you. The first one would be, yeah, like this kind of, I just, when I think about like these post training recipes, this is something that I have a poor understanding of. But like, how do you think about mixing the data? Like 20%, I don't know, 80% normal, sort of. You should have an answer. Yeah, how do you think about that?
Yeah, that's exactly what we wanted to test. So we tried these different mixtures. And essentially, what we saw was the more we have the ground truth answers, the more it seemed to improve the overall performance. But we didn't really see a change in the like abstention ability or the ability to say, I don't know, at least for this particular fine tuning setup. I would not make any universal claims of like, oh, this just doesn't work, or, fine tuning in this way can never solve abstention. It was just that, for this particular setup where we have these data mixtures and this LoRa fine tuning in these models, we couldn't get it to work super well. That doesn't mean that, it doesn't work in general, but I do think it is not a straightforward solution.
Uh, like something I like to do when I'm trying to like train a model to do something is to sort of like overfit on purpose to just kind of like make sure I'm even doing something. That's honestly why I do it
Yeah.
mostly. Did you try that? Maybe just try to maybe 100% of the sample is I don't know, just to see if you could just push it in that direction. Yeah.
Yeah, and we did see some success, just pushing like all the way to I don't know, but it wasn't like a clean cutoff of like, and now if we cut it to 50%, can we get 50% abstention? It seemed like not predictably.
Hmm. And so then I guess my second kind of quick question would be this sort of the state of fine tuning, because I guess you have kind of like supervised fine tuning, and then now you have all these class of RL algorithms like
Mhm.
GRPO, and
Mhm.
I think maybe if I could just kind of explain, because you might have more of a, I have a kind of a basic understanding of this. So the way that I understand it is supervised fine tuning is it's, still doing that task of predicting the next tokens, but you've labeled this ground truth. And I think there's a big concern around that just totally causes the mode collapse of this data set that you've curated.
Yeah.
Whereas RL, you sample multiple outputs from the model, and then you have like a preference rating. Yeah, do you mind explaining further what you use to train this model and just overall your thoughts on that?
Yeah, so we were using supervised fine tuning in this setup. I do think there is a space for more of like a DPO, GRPO, like preference tuning, especially because like it's hard in the case where you have an exact ground truth answer that you want, but in many cases, say we want like an accurate calibration of how certain the model is, something like, human label preferences could be really valuable for that. We also have, this is like somewhat tangential, but on on the topic of supervised fine tuning, a project I've been working on recently is just trying to like understand some of these phenomenons in that context specifically of supervised fine tuning. So insufficient context, we saw this interesting uh, like results where the model gets the question right with insufficient context. So it's like somehow we're unlocking this ability that, the model shouldn't have been able to get the right answer, but it does somehow, and it's sort of mysterious. We're sort of seeing the same thing with fine tuning. So, specifically, the result we found is that even just fine tuning, say 100 parameters, like a very, very small number of parameters that are just randomly selected, like not even, trying to choose the exact right parameters, we're able to recover a lot of the ability of fully like supervised fine tuning across the entire model on the whole data set. So it seems, it's sort of supporting the same hypothesis, which is that we might be more so like unlocking some latent capabilities more so than we are teaching something new to the model.
Oh, that's super cool. I hadn't thought about it like that. I had thought about well, yeah. So I guess this kind of LoRa thing. I think the sparse fine tuning, just that whole. I think just that whole finding was so surprising. And I think
Yeah,
sparsity was already. Yeah, maybe it's related. I don't know if you're familiar with like it's the lottery ticket hypothesis paper, where
yeah,
yeah, it's a
exactly.
classic one.
Yeah, super related. Yeah, definitely.
Yeah, that's so cool. Yeah, it's really interesting. I guess maybe sort of maybe a broader question of the mechanics of fine tune, or I guess maybe one more question about the technical details of this would be: is LoRa still like the detail? Is that still the state of the art of how people are fine tuning LLMs? There's doing this kind of sparse update.
That's what I'm doing. So as I'm trying to investigate like sparse fine tuning, especially for this, recent work on how few parameters can you really fine tune? Something like LoRa really makes a lot of sense, um, especially for even just from like an implementation standpoint. Like it's just a little bit easier to handle when you're just fine tuning a few parameters. But I am excited about some of the recent developments.
Yeah, awesome. I don't know too much about it. I guess I can't keep going to that one. But I do have kind of a broader question, which is about fine tuning LLMs for particularly for retrieval augmented generation. I think not just the kind of retrieval aware fine tuning, but now also maybe having an output about sufficient context rating and using that. What do you think? Do you think that maybe that will be the future of the best model for RAG? Will be one that's particularly fine tuned for RAG compared to just say like the latest and greatest generally capable LLM?
Yeah, I don't have experience fine tuning a model for RAG, but based on the experience in this paper and in this work, I would not be surprised if that's the case. Specifically because we see new failure modes with RAG that we didn't see without RAG. Like we see the model, previously did well at abstaining, previously did well at mitigating hallucinations, and now you add RAG and suddenly it loses that ability. It wouldn't surprise me if a model fine tuned for RAG is able to mitigate some of those failure modes.
Yeah, yeah, that's what I have to suspect as well. And then I think the kind of space of fine tuning LLMs has is going to take off quite a bit. It's kind of interesting. I think maybe the llama. Well, actually, I actually will. I won't give my hot takes on. I'll save that. Also, so I did want to ask, kind of broadly, with this work, what kind of directions for the future inspire? I mean, my next question will be broadly about AI, but particular to this work, what kind of future directions did this work inspire you to want to look into next?
Yeah, I sort of mentioned this idea about what is really going on in these models when they have this unexpected behavior, and how can we better understand what I'm calling like their latent capabilities, which is, you know, things that if we just prompt in the right way or just give, even a little bit of extra information or get the ball rolling in the right direction, suddenly we can unlock these capabilities. In some cases, that might be just, fine tuning a few parameters on a small data set. Suddenly we're able to unlock this capability. I'm really interested in those types of directions.
Also, I mean, I'm curious if you're interested in that kind of mechanistic interpretability, trying to get. Yeah, I imagine it definitely inspires my interest further in this parametric knowledge conflict thing. The fact that they can answer the questions without the retrieved context. Yeah, do you find that to be an interesting area?
Yeah, I do. I've definitely been working, like, I work broadly in interpretability and safety, and my work has been more on the like kind of application driven and like specifically like, task driven side of like how can we understand what the model is doing in this context? How can we make it safer to use for these tasks? But I am excited to see what happens with mechanistic interpretability.
Yeah, I think you could have like I need to get into the mechanics of the activations of the neural network to understand, or I can have like another podcast we did was with Leonard Tang from Hayes Labs, and they have a library called Verdict, and the headline being scaling judge time compute. Sorry, what the category is called scalable oversight. I'm sure you,
Mm.
yeah, and that kind of like we're going to design compound AI systems, agents, Patronus AI. They have this system called Percival that's like debugging agents and yeah, what do you think about that kind of like scalable oversight? Is that term picking up?
Yes, yeah, I'm familiar with the scalable oversight kind of area of research. I'm excited about that. It's something I'll be working on soon as well. And yeah, I kind of like broadly, I'm really interested in like the safety and alignment space, like building in mechanisms like this abstention wrapper, just like one piece of making these models safe for people to use. But it's really hard to uh, like scale essentially. The scalable oversight is trying to solve that problem where it's hard, to do like just red teaming from a, manual, like let's have all of our engineers try and jailbreak the model perspective. Like these types of automated, whether it's debugging or alignment kind of safety, I think is going to be really important.
Yeah, it's super interesting. I guess like I'd always interpreted it as like it's kind of like an adversarial attacking type of mindset, but then I guess adversarial attacking had this funny shape where it was like a gradient attack on the input such
Yeah.
that it's imperceptible. I think that it's I think I don't really know if I'm a huge fan of that, but I think when you're adversarial attacking, then you're keeping it also like on the distribution of realistic inputs. Yeah.
Yeah, definitely. Yeah, I think that was, a common criticism people had of like early work on adversarial attacks was like, yeah, sure, the model doesn't do well when you like add these gradients, but it's so unrealistic. And I do think like, we're seeing with LLMs, it's not as unrealistic. Like these are kind of prompt-based techniques that are in the well within the space of realistic inputs.
Yeah, this topic and our whole discussion about sufficient context is maybe making me think about the adversarial attack of maybe I could insert a particular document into the knowledge base that now is always going to be retrieved. It's always going to be like k equals one because of some way you've designed it, and then it's going to throw off the model. Or yeah,
Yeah, totally. Oh, that's a super interesting idea.
yeah, also, yeah, awesome. Well, Haley, it's been so much fun discussing all these ideas in the paper. I've learned so much from this conversation. There's so many interesting takeaways. I highly recommend people just go through the sort of, and the paper is extremely well written. I generally just really
Oh,
love
thank you.
reading through it. Awesome. So this is kind of a question I love to anchor the podcast with, maybe broader than a lot of the questions that are kind of like technical interviews on these particular research areas. But just kind of like broadly, what directions for the future of AI excite you the most?
Yeah, I'm excited as we integrate these models into daily life, and especially as we integrate them into high stakes decision making. I'm hoping we can really invest the research we'll need to ensure these models are safe and work well for everyone, across diverse populations, diverse users, and, are safe and aligned with our goals and our values. So that's the research I'm really keeping an eye on, and I'm really hoping we can invest in.
That's amazing. I have to ask just I've been listening to a few Jeff Hinton. He's been doing some talks lately, and sometimes it scares me. There's something about like when I guess the idea that like we can't even understand the idea of what a super intelligence is. I guess yeah, just kind of asking you as an expert in this kind of field. I just would love to know more about how you sort of define that, how you think about that term, super intelligence.
Yeah, that's something I've been thinking about. I do think it's a balance, right? Like we need to worry about these. I think there is value in focusing on some of the existential risks and, you know, what are the risks that are like totally unanticipated, and at the same time saying like what are the risks we are dealing with now as AI is being used for things like facial recognition, for medical decision making, for loan applications, for, diagnosis and treatment and deciding like who gets a kidney transplant. Like it's being used for all of these things already that are we really need like safety and alignment for. And at the same time, keeping our eye on the ball long term, what are kind of the broader risks that we haven't anticipated yet.
Yeah, awesome. Well, Haley, thanks so much for joining the Weaviate podcast. Congratulations on the publication of sufficient context and acceptance into ICLR. That's super awesome achievement. And yeah, it's such an awesome paper. Thank you so much.
Thank you. It's been great.